Hi, welcome to Mathematics of Chemistry. My name is Dr. English. Today we're going to be talking about mole-to-mole conversions. Specifically, we're going to be looking at determining mole ratios, using mole ratios in calculations, and then finally some practice problems at the end. Mole-to-mole conversions. We can use our knowledge of balanced chemical equations to predict the moles of products that a given number of moles of reactants will yield. So what we're going to do is we're going to determine mole ratios. What number of moles of atmospheric oxygen will be produced by the decomposition of 5.8 moles of water? So our given here is 5.8 moles of water. It's the only number that appears in this problem. What we want is moles of O2. In order to do this problem, we need the following balanced equation. And when you do a mole-to-mole problem, you will always be presented with a balanced equation on the Regents exam. So if we look at this balanced equation, we can see that it's a decomposition reaction. So we have 2 moles of water that decomposes into 2 moles of hydrogen gas and 1 mole of oxygen gas because there's an assumed 1 in front of the O2. Again, it all comes back to the balanced equation as we see above here. From this equation, we can state that for every 2 moles of water used, 2 moles of hydrogen and 1 mole of oxygen are produced. So it's all about these coefficients that we see up in the balanced equation. And remember, there's an assumed 1 in front of the O2. So the mole ratio for this problem would be 1 mole of O2 for every 2 moles of H2O decomposed. So our given here is 5.8 moles of water. What we want is moles of O2. So we start off always by writing our given, 5.8 moles of water. I'm going to do a multiplication sign and a line. If I start with moles of water is going to go on the bottom of my ratio. I want moles of O2, so that's going to go on the top of my ratio. Now the question is, where do we get these numbers? These numbers come from the balanced equation. So if I look up at my balanced equation, I can see 1 mole of O2 as I see right here, and 2 moles of H2O, which I have right here. So those numbers that are in this ratio as we do these mole-to-mole problems come from the balanced equation, always. My next step is to cancel my units. So moles of H2O cancel moles of H2O. Then I'm going to do 5.8 times 1 divided by 2, and my final answer will be 2.9 moles of O2. And again, I want to consider significant figures here. So I start off with 2 significant figures in my given. My final answer will also have 2 significant figures. Let's look at another example. Using mole ratios in calculations. Calculate the number of moles of oxygen required to react exactly with 4.3 moles of propane. And the formula for propane is C3H8 in the reaction described by the following balanced equation. So we're given a balanced equation. C3H8 plus 5O2 yields 3CO2 plus 4H2O, common combustion reaction. My given here is 4.30 moles of propane. What I want is moles of oxygen. So the conversion factor that I'm going to look at is my ratio between moles of oxygen and moles of propane. Again, I get these numbers from the balanced equation listed right here. So here's 5O2, and here's an assumed 1 in front of the propane. I'm going to start out by writing my given, 4.30 moles of propane, my multiplication sign and a line. If I start off with moles of propane will go on the bottom of my ratio. I want moles of O2. The 5 and the 1 are coming again from the balanced equation. Once I have this set up, I want to make sure that my units cancel. Moles of propane cancels moles of propane. I'm left with moles of oxygen, which is what I want in the end. Then I do 4.30 times 5 divided by 1, and my final answer will be 21.5 moles of O2. So I start with 3 significant figures, I end with 3 significant figures. Let's do one more practice problem. Hydrogen sulfide gas reacts with oxygen to produce sulfur dioxide gas and water according to the balanced equation. So here's our balanced equation right here. How many moles of oxygen gas are required to react with 5.6 moles of hydrogen sulfide? In this problem, there is only one number given. So therefore, that's my given. So my given is 5.6 moles of hydrogen sulfide, H2S. I want moles of oxygen gas because that's what they're asking for. So I want moles of O2. So the first thing that I'm going to do is write down my given. 5.6 moles of H2S, multiplication sign and a line. I'm going to put moles of H2S on the bottom. I want moles of O2. Then I'm going to look at my balanced equation. The coefficient for H2S is 2, and the coefficient for O2 is 3. So the 2 is going to go on the bottom, and the 3 is going to go on the top. I'm going to put an equal sign, and then I need to make sure that my units cancel. So moles of H2S cancels moles of H2S. So I'm going to multiply together 5.6 times 3 divided by 2, and my final answer will be 8.4 moles of O2. And that's another example of how to do a mole-to-mole problem. So what did you learn? We talked about determining mole ratios based on a balanced equation. We talked about using mole ratios in calculations, and then finally some practice problems at the end. Need more help? Feel free to contact me. Have a great day.